Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve a question from Probability and Statistics 1. And question number 6 belongs to paper 9709/52 for the session May June 24. Let's read question number 6. The residents of Mahjong were asked to classify their local bus service. 25% of residents classified their service as good, 60% of residents classified their service as satisfactory, and 15% of residents classified the service as poor. Question number A says a random sample of 110 residents of Mahjong is chosen. Use a suitable approximation to find the probability that fewer than 22 residents classified their bus service as good. Well, so the clue word of this question is approximation. Approximation is the clue word. So whenever such word arises in the question, we will understand that the distribution is given in binomial method, whereas we will have to convert it into a normal distribution. So for binomial method, as it is given in binomial method, we know the parameters of binomial method are n. Here n is what? N is total number of residents, means 110, and p is the probability of the bus service as good. Okay, for good the probability is what? 25%, means 0.25. So we will require one more symbol, which is q. Q is actually 1 minus p. P is the probability of that required distribution, and q is just subtraction from 1. So 1 minus 0.25 is 0.75. So these are the three information we need. As we have already understood that the distribution is in binomial method, so x belongs to binomial. X belongs to binomial, and the parameters for binomial are n and p. So n is the total number of experiment, which is 110, and p is the probability, which is 0.25, and we are going to convert this binomial distribution into a normal distribution. So x belongs to normal distribution, and the parameters for normal distribution are mean as well as variance. So mean, what is mean? Mean is n into p. Np is mean. If we multiply 110, so np, our np is the mean. Okay, np is mean. For mean is the parameter for normal distribution. So let us multiply 110 by 0.25, and it is going to be 27.5. 27.5. And the other parameter of a normal distribution is npq, that means variance. Variance is npq is actually variance. Okay, means variance can be denoted by sigma square. So our mean has become 27.5. Let's see the variance. Variance is going to be npq. Variance is the product of npq. So if we multiply 27.5 by q is 0.75, so it is going to be, how much is it going to be? 20.625. So it is 20.625. 20.625. 625. So we have written this is mean and this is variance. Variance is the square of standard deviation, and we denote standard deviation as sigma. Well, then let's see what to do in the immediate next step. Okay, in the immediate next step, they have told us to find what? Use a suitable approximation to find the probability that fewer than 22 residents. Fewer than 22 residents. So we'll find probability of x is less than 22. Here there is a very crucial point to be remembered, which is we are converting the distribution is given in binomial, which is being converted to normal, but there is a very delicate difference between these two distribution. Binomial distribution is applicable for discrete random variable, whereas normal distribution is applicable for continuous random variable. So we will have to do the continuity correction, because a discrete random variable is going to be converted to a continuous random variable. So in this case, continuity correction is a must. So less than 25, less than 20, so less than 22 means if we rectify, I mean, if we do continuity correction, then it is going to be less than 12 to 21.5. I think you have understood my point. As we are converting a distribution from binomial, I mean discrete random variable, to continuous random variables, and then we will have to do the continuity correction. So less than 22 means it's 21.5. Well, then we will find the z-score of this. Z-score, z less than, and you know how to write this, 21.5 minus mean. How much is the mean? Mean is 27.5, and over standard deviation. Standard deviation is sigma, which is square root of 20.625. Well, after that, let me write just below this. So let us calculate this probability of z less than, if we, it must be negative. Look at this, our mean value is greater than the score, so it is negative. Now if we divide 6 divided by square root of 20.625, it will be 1.321, 1.321. Well, then for this z score we will have to find corresponding probability. But before that, let me show you something else. Look at this. Suppose this is our normal distribution curve, and you know normal distribution curve is always symmetrical. Well, and here is the mean score, I mean 0, and our z score is negative 1.3. This is 1.3. As it is negative, it is lying on the left side, and we will find the probability on the left side. Look at this, less than z score. So our probability is, this is our probability to be obtained. Let me change the ink. Okay, suppose this is our probability. Okay, this portion is our requirement. This is required probability. So what we can do, look at this, as the normal distribution graph is symmetrical, so here from the mean line it will be 1.3, it will be exactly same. So what we will do, we will just, let me draw one more curve. This is 0. As we require this portion, look at this, so this portion is definitely equal to this one, this portion, because the graph is symmetrical, isn't it? Now the question which may arise, that why are we undergoing such complication? Actually, we are going to use our normal distribution table, and in the normal distribution table there is no probability given for any negative z-score. So we will have to convert it into positive z-score. So one thing is very sure, we require the probability of this portion. This portion is our requirement. Well, this is the probability we required, and here 1.3 is the z-score. Now how to find the probability of this portion, because this is very tiny. The easy way is, we will just find, will subtract. If we subtract this portion, because always the probability lies on the left side of the z-score, okay, according to the normal distribution table we have. Okay, we are going to use the hard copy of that. So the probability, we require this portion, this portion is required by us. So what will we do? From whole of the probability means 1, from 1 we will subtract this portion, because the corresponding probability given in the normal distribution table is always lying on the left side of the z-score. So easily we can find the probability for corresponding probability of z-score of 1.3. Then if we subtract the left part from whole of the probability, we will get our required probability. So how to write this? We will just write 1 minus 1 minus probability of z less than 1.321, because we know there is no probability given in the probability distribution table for any negative z-score. So let's see, using our normal distribution table, when z-score is 1.321, let us find the probability. Probability is going to be 1.321, so it's 0.9066 plus 2, so it is 0.9068. So finally, what will our probability be? Our probability is going to be, if we do the subtraction, it is going to be 0.90903. So this is the approximation of the given data. Now I'm going to show you how we got this probability for this corresponding z-score. Well, and I think so long you have understood that basically we were searching for this part. This part is our probability. This part, this less than 1 point negative 1.3, but there is no probability given in the probability distribution table for any negative z-score. So what do? We just reverse this, because the curve is always symmetrical. Then we have got that we require this right part. This is our norm, our required probability. This part is our probability. So for this, what we have done, so from whole of the probability we just subtracted the left part. If we subtract the left part, I mean z less than 1.321, then we have got from whole of the probability, then we have got our required probability. So this is how we can solve. Now let me show how to find our corresponding probability for this z-score. Don't forget that our z-score is 1.321. Well, let's write this. Let me get the page. This is our normal distribution function, table of normal distribution function. So let's see how much was our z-score. Our z-score was, let me zoom it out. Yes, our z-score was, we have not forgotten that our z-score was 1.321. Okay, This is our Z score. So let's see 1.3. 1.3 is over here and 2. 2 is over here and the last digit is 1 over here. Okay. So let us see which one is our corresponding probability for this. We will reach over here and here it is. So our corresponding probability is this 0.90 0.9066. Well, after that there is 1. So let's reach until 1. It is nothing but 2. So these 2 should be added. How will we add this 2.000 then 2? So ultimately our probability is going to be 9068. So this is what we have used as our, this is our required probability, which was 0.9068. Let's see whether we have written 0.9068 or not. Yes, we have written 0.9068. Then from whole of the probability we have just subtracted this greater portion to get our required probability. Let's move on to question number B. Question number B says, yes, that is question number B, which says that for a random sample of 10 residents of Mahjong, find the probability that fewer than 8 classified their bus service as good or satisfactory. Well, so this is simply a binomial distribution because total number of experiments have been given. So x belongs to binomial. We can start our writing, and the parameters for binomial distribution, you know, the total number of experiment as well as probability. So total number of experiment is 10 and probability of each of the experiment is, look, the probability will be good or satisfactory. Let us see how much was the probability of good or satisfactory. For good it was how much? Yes, this was the question. Let me erase this part. If we erase this, we will get for for good there is 25%, means 0.25, or satisfactory, for satisfactory probability is 60%, that is 85%. So it is to be added because they have told, look at this, they have told us to find the satisfactory, good or satisfactory. Okay, so for good or satisfactory we will have to do addition, as this is or. So 25 plus 60 means 85. So our probability is 0.85. These are the parameters. Now we will find, they have told that probability of x less than, fewer than 8 residents. So a x less than 8. Now, x less than 8, what does it mean? If we explain in words, it is going to be, suppose 7 people classified the service as good or satisfactory, or there might be 6 people, or there might be 5 people, or there might be 4, 3, 2, 1. So it's a long calculation. For each of these individual probability, it will take a huge time to calculate our probability. Rather, we should reverse the scenario. If we reverse that, less than 8 means out of 7 it may be 6, 5, 3, 4, 2, 1. If we subtract this probability from whole of the probability of 1 minus, that means how many people didn't classify, how many, only 8, 9, 10, 3 people didn't classify. So we can write probability of x equal to 8, or probability of x equal to 9, that means 9 people didn't classify this as good or satisfactory, minus probability of x equal to 10. 10 people didn't classify this as good or satisfactory. I think you got my point. How did we do? They have told that less than 8 people classified the service as good or satisfactory. That means out of 10, 8 people didn't 8 people might not classify this as good or satisfactory, or 9 people might not classify this as good or satisfactory, or 10 people. So from whole of the probability, if we subtract 8 probability of 8 people, or probability of 9 people, or probability of 10 people, then we will get our required probability. So let's start calculating. So 8 people out of 10, out of 10 choose 8, out of 10, 8 people classified this as what? Good or satisfactory means 0.85. How many people? 8 people. Then rest 2 people didn't classify. So Q is 0.15, because 1 minus 0.85 is 0.15. 2 people didn't classify. So we are just writing here 2 for the first case. Then in the second case, 9 people out of 10. 10 choose 9. Out of 10 people, 9 people classified that the service was good or satisfactory. So we will multiply, raise it to 9 times. Then only one people. If 9 people classified this as good or satisfactory, then one people didn't. So only one people, 1 5 means 1 person didn't classify this as good or satisfactory, minus, or 10 people out of 10 people classified this as good or satisfactory. 10 choose 10, that all 10 classified this as good or satisfactory. So 0.85 raised to 10, raised to 10. And no person classified this as good or satisfactory. So no people means 0 people. Well, this is what our scenario is. So let us do the calculation. Yes, this is our step. So how can we write? Let me start from here. So it is going to be 1 minus 10 choose 8. How to write this? 10 factorial over 2 factorial and 8 factorial. 0.85 raised to 8, as well as 0.15 two times. 15 2 times, minus 10 factorial. I am doing this actually manually. I feel it comfortable while doing manually. You can use this using your calculator in a shortcut method also, but I am showing how to do this manually. 10 factorial over 1 factorial into 9 factorial, and 0.85 raised to 9, and 0.15 once, minus 10 factorial 10 is actually 1. That means 10 people, from 10 people can be chosen in one way. That's why it is actually 1. Yet I am showing, as I have shown the previous one, in elaborated format. So it will be 10 factorial over 10 factorial and 0 factorial. 0 factorial is also 1, into 0.85 raised to 10. And we know if exponent is 0 on any quantity, then that produces 1, so we don't need to write 1. Let us write the in the next step. What is it going to be? Equal to 1 minus, so 10 factorial means 10 into 9 into 8 factorial into 8 factorial, okay, over 2 factorial into 8 factorial. 0.85 raised to 8 and 0.15 raised to 2, minus and 10 factorial can be 10 into 9 factorial over 1 factorial means 1, so it is unnecessary to be written, and 0.859 times into 0.15, 0.15 minus, if we divide 10 factorial by 10 factorial, it's 1. So simply we can write that 0.85 raised to how many times? 10 times. This is actually manual way of solving any binomial distribution. Well, after that, what is it going to be? 1 minus, if we dissolve this, it is going to be 2 factorial means actually 2. So 5 nines are 45. 45 into 0.5 raised to zero point 0.5, 0.5 raised to 8 times, and 0.15 squared, minus, if we dissolve this 9 factorial by 9 factorial, so this is nothing but 10. 10 into 0.85 raised to 9 times into 0.15 minus 0.85 raised to 10 raised to 10. Now using our calculator we will get our probability is going to be, let me use my calculator, 1 minus 45 into 0.85 raised to 8 minus 0.15 square minus 10 into 0.85, 10 into 0.85 raised to 9 into 0.15 minus 0.85 raised to 10 equal to, it is going to be 0.1798, 0.1798. If we round it up to three significant figure, it is going to be point, it is going to be 0.180. 79 means 80, 0.180, that is what our probability. Okay, so this is how we can solve this very simply. So it was actually a binomial distribution because at the beginning they have given us the they have already given us the total number of sample, which is 10, and the probability has also been provided. So they have to less than 8 people selected and classified. So the question told us that less than 8 people means actually 7 people, isn't it? 7 people classified the service as good or satisfactory. Okay, that means we will have to find the probability of 7 people, less than 7 people, there may be there less than 7 people, sorry, 7 people. Less than 8 people means there might be 7 people, there might be 6 people, there might be 4 people, or there might be 0 people, or 1 person classified the service as good or satisfactory. So it's a long calculation if we individually calculate each of them. Rather, what have we done? If 7 people classified this as good or satisfactory, that means 3 people didn't classified this as good or satisfactory. So we have found the probability of these 3 people. If they, what is the probability of classifying this good or satisfactory by these 3 people? After that we have subtracted these 3, the probability of these 3 people who might classify this as good or satisfactory. After that we have subtracted the probability, sum of the probability of these 3 people from 1, then we have got the probability of 7 people who classified the service as good or satisfactory. Let's see the next question. What does the next question say? The next question says three residents of Mahjong are selected at random. Find the probability that one resident classified the bus service as good, one as satisfactory, and one as poor. So it is very simple actually. There are 3 person. three people has been chosen. Out of three, one has chosen. We don't want to undergo any complication. Simply we will write. So first one, suppose first one has one person, one of three. Okay, so one of three has classified this as good. For good it was 0.25. Okay, into, and the other one, it is not addition, it is and the second one, I mean the another person, one of the three classified this as satisfactory. For satisfactory the probability was 0.65, and the third person, not third person, that means one of the three classified this as poor, and probability of classifying as poor is 1.5. Okay, so this is 0.225 plus 0.65 plus 1.5, it is total probability. Okay, now there is only one confusion. Look at this, we don't know that whether first person told that it is good, or second person told that it is satisfactory, or third person told that classified that as poor. There may be vice versa, that means everyone can change their position. Okay, so this way we'll have to make a order, that means an arrangement is required. How can we do? It is 3 factorial ways. Okay, 3 factorial ways, because first one may go to the third place, and third one may come to the second place, or first one may go to the second place. So there are different arrangements. So for the arrangements, what do? We just use the 3 factor 3 factorial. So 3 factorial means actually 6. Let us multiply by 6. So it is going to be probability. Did we write the probability correctly? No, there is something missing. It is not 65, actually 60%. 60% of the residents classified this as satisfactory. Let us see. Let us go back to the first page. It was what? 20%, 25%, 25%, 60%, as well as 15%. So 25, 60, and 25, 60, as well as 0.15% was the each of the probability. So if we calculate these 0.25 into 0.60 into 0.15 multiplied by 3 factorial, it is going to be 0.1 0.135 is the final probability. I think you have understood here. This is one of the very simplest question, that there are three people. We have multiplied the probability of each of these three, but order matters. We don't know whether the first one classified as good or satisfactory or poor, or the third one classified, as we don't know the specific order. That's why we will have to write all of the orders in 6 different ways, means 3 factorial ways. In 6 different ways they can be chosen, I mean, the probability can be calculated. So that's all about the question number 6. It was question number A. Then this one was B as well as C. So thank you all for being with me. In the next video, inshallah, we will talk with each other. Fi amanillah.